All right, in this video, I'll be talking about how to factor quadratic equations. So I'm going to be teaching two methods in this video. We're going to be teaching the method where we factor our quadratic by multiplying two numbers that multiply to the constant, and then adding two numbers that add up to the linear term or the middle term. And the second method will be factoring by grouping. So let's go ahead and look at a few examples, okay? So we have x squared plus 4x minus 5 is equal to 0. Here, what we want to do is look at our constant term, and then we have -5, and we want two numbers that multiply to -5, but add up to 4. And here, what we just do is just check and guess, and we would see that after finding a few values, we would see that we have -1 plus 5 works, because 1 times, or -1 times 5 is equal to -5, and 5 minus 1 is equal to 4. So we could rewrite our quadratic as x minus 1 times x plus 5. And we could verify this by expanding our factored quadratic. So if we have x times x, we get x squared, and x times 5, that is plus 5x, and minus 1 times x, that is negative x, and minus 1 times 5, that is minus 5, and pretty much combining like terms, we have 4x, which is indeed our original quadratic. So that is just the main idea behind this method, right? You just have to find two numbers that multiply to the constant, basically the number without an x in front of it, and then find two numbers that also at the same time add up to the middle term, or the term with a x in front. So let's go ahead and look at another example. So let's say we have x squared plus 8x plus 12 is equal to 0. So let's go ahead and look at 12. So we have 12, and we split that into two numbers that multiply to 12, but also add up to 8. And what are those two numbers? We could say 2 and 6, because 2 times 6 is equal to 12, and 2 plus 8, or 2 plus 6, is equal to 8. So we could rewrite our quadratic as x plus 2 times x plus 6 is equal to 0. And to find the roots of this, all you have to do is simply use the zero factor property, where we have x plus 2 is equal to 0, and x plus 6 is equal to 0. And then here, the reason we are doing this is because if we say let let this be equal to 0, then it's going to be 0 times whatever is this number right here, and 0 times the number is 0. And similarly, we could say the same logic for this one. We could say if this is 0, right, and 0 times whatever this is right here, some number, it is still going to be 0. So that is why we set each factor equal to 0. Because if one product is equal to 0, then the entire equation is going to become 0. So solving for x, we just subtract 2 from both sides, which then gives us x is equal to -2. And on this one, x plus 6 is equal to 0. We subtract 6, and we get x is equal to -6. So that is pretty straightforward. So we're going to do a few more examples. So let's go ahead and look at x squared plus 7x plus, let's say, 6 is equal to 0. Let's look at 6 again. And we're going to have to find two numbers that multiply to 6 and add up to 7. And those two numbers, if we go ahead and look at the possible factors of 6, we would see that 6 times 1 is equal to 6, and 6 plus 1 is equal to 7. So our quadratic could be rewritten as x plus 6 times x plus 1. And that is equal to 0. And here what we're going to do is simply just use the zero factor property again. So you have x plus 6 is equal to 0, and x plus 1 is equal to 0. Solving for x, we get x is equal to negative 6, and x is equal to negative 1. So that is that example. And one more we're going to do is x squared minus 5x plus, actually, let's say it is minus 84, and that is equal to 0. So here, now this one might be a bit trickier because of a bigger constant. So it is negative 84, and we're going to split it into different factors. So we're going to go ahead and divide by 2, and we're going to have 2 times negative 42. That does not add up to 5, so that is not a combination that works. So we could say that that doesn't work. And here we look at 4 times negative 21. That doesn't add up to negative 5, so it doesn't work. And we could split 21 into 3 and times 7. And we're going to just bring that 3 to the 4. So we have 12 times negative 7. And we see that 12 minus 7 gives 5, but not negative 5. So all we do is just switch the sign. And then we have negative 12 plus 7, which is negative 5, and it multiplies to 84. And the reason I got 12 is because we have 4 times negative 21. We could split this as 4 times 3 times negative 7. And I multiplied 4 times 3, which then ended up becoming 12 times negative 7. Which then after that, I simply just factored out a negative 1, which then finally gave negative 12 times 7. So then these two add up to negative 5. So we could finally rewrite our quadratic as x minus 12 times x plus 7 is equal to 0. It doesn't really matter how you write your factors. I could have written as x plus 7, but it doesn't really matter the way you order your factors. Just a little reminder. And by the zero factor property, we're going to have x minus 12 is equal to 0, and x plus 7 is equal to 0. And then here solving for x, we get x is equal to 12. And finally, x is equal to negative 7. So yeah, we're going to go ahead and look at factor my grouping now. So here we're going to go ahead and look at quadratics where a is not equal to 1. So here we have 2x squared plus 9x plus 10 is equal to 0. So how do we factor this? Well, we could try various methods, but we're going to simply do the AC method, where we have 2 times 10, that is 20, and we want to find two numbers that will multiply to 20 and add up to 9. And at first glance, you would just have to look at the factors of 20, which if we split 20 into factors, we would see that we could have 10 times 2, or 5 times 4, or 20 times 1. But we see that 20 times 1 isn't going to work. Neither will 10 times 2. But the only combination is going to be 5 times 4. So we have 5 and 4. And here we see that we have 5 times 4 is 20. And 5 plus 4 is 9. And unlike the other example where we did x plus 5 times x plus 4, we can't do that because of the fact that our leading coefficient, or x squared, is not equal to 1. So what we're going to do is look at our middle term and realize that we could pretty much split it as a sum of 5x plus 4x, which then is going to give 2x squared plus 4x plus 5x plus 10. And that is equal to 0. And what we could do, right, is now what we could do is go ahead and simply group and then factor out what we want to factor out later on. So here, from 2x squared plus 4x, we could factor out a 2x. So 2x times x plus 2. And then here we could factor out a 5. So plus 5 times x plus 2 is equal to 0. And what we notice is that we can factor out an x plus 2. So we have x plus 2 times 2x plus 5, and that is equal to 0. And if we go ahead and factor, or pretty much expand our two linear factors, we would have 2x squared, and then 2, or x times 5, that is 5x, and plus 2 times 2x, that is plus 4x, and then plus 10. And 2 times 5 is 10. And adding 5 and 4, we get 9, which is indeed our original quadratic. So now that we expanded our expression, we can go ahead and solve via the zero factor property, which here we have x plus 2 is equal to 0, and 2x plus 5 is equal to 0. And solving for x for the left one, right, is going to be x is equal to negative 2. And for the right equation, 2x plus 5 is equal to 0, we're going to do just one extra step. We have 2x is equal to negative 5, dividing both sides by 2 to get x by itself. We get x is equal to negative 5 over 2. And those are our solutions to our equation. Let's go ahead and look at another example. So we have 4x squared minus 3x minus 10. And that is equal to 0. So what we're going to do is go ahead and repeat the same process as the previous example. So you have 4 times negative 10, that is negative 40. And what we're going to do is find factors of 40 that multiply to 40 and add up to negative 3. Oh, what we can do is find factors of 40. So we're going to say, okay, so we know 20 times 2, or negative 20 times 2 is negative 40. Negative 10 times 4, that works. And 8 times 5 works. And we see that if we look at 8 and 5, we know that if we add or subtract them, we will get either positive 3 or negative 3, and which is what we want to get, negative 3. So you want the bigger number to be negative because 8 is going to be bigger than 5, so it's going to be negative 8. And 5 is going to be the positive number because negative 8 plus 5 is equal to negative 3. So we found our factors. And what we could do is we're going to split again our x term into negative 8x plus 5x. So we have 4x squared minus 8x plus 5x minus 10. And that is equal to 0. And we're going to go ahead and group like so. And then we see that we could factor out a 4x from 4x squared minus 8x, which will be 4x times x minus 2. And then plus, and then we could factor out a 5 from 5x minus 10, which would be 5 times x minus 2 is equal to 0. And factoring out a x minus 2, we would have x minus 2 times 4x plus 5. And setting each factor equal to 0, x minus 2 is equal to 0, and 4x plus 5 is equal to 0. We see that for the left factor, x is equal to 2, and subtracting 5 from both sides, we have 4x is equal to negative 5. Dividing 4 to both sides, we have x is equal to negative 5 over 4. But yeah, that is just a few examples of factoring by grouping and finding two numbers that multiply to the constant term and add up to the linear term, or the middle term in simple words. So yeah, thank you for watching and have a good day.